Hello everyone, welcome back to another video. And today I'm going to talk about something related to hardware or infrastructure. So we all know how fast the infrastructure space is changing, particularly the AI hardware space. And Google Cloud Next just wrapped up. I'm not sure if you're following it up, but they dropped something very huge, which is uh, something great for the AI backend or workloads. I'm talking about Ironwood TPU. I'll talk about what TPUs are, why this announcement is very significant. But why am I talking about hardware, on this particular channel? Because this particular thing is too big to miss for anyone, be it software engineers, SRE, DevOps, etc. Anyone, right, in the IT field, because the space is evolving so rapidly that you can't miss this thing. And as a DevOps engineer, also you will be responsible for managing deploying or scaling this AI infrastructure, right? So let's dive right into it. So let's start with what are TPUs. So let's start with CPUs, right? So I'm sure all of you will know that what a CPU is, right? Central Processing Unit, which are very good at sequential tasks, very simple tasks, etc., which mostly all the laptops or the desktops have, right? But then after that comes GPU, right? Graphical Processing Unit. Earlier they were, for graphics, but now they are a big thing in the AI or ML model training, right? So they serve as the base or core for that model training, right? And the gaming industry had a huge role to play in it. It's, the past decade, the gaming industry pushed a lot for this particular GPUs, and now we are here. AI models are being trained on top of it, right? After that comes TPU or Tensor Processing Units, right, which is designed by Google specifically for massive matrix calculations, right? For the tensor calculations which are needed for the machine learning models, etc. So we are going to talk about the TPU and this Ironwood TPU basically. So this Ironwood TPU is Google's seventh generation TPU. So before this, there was sixth generation, which the code name was Trillium. Then there was fifth generation V5P, etc. And Google is saying that this is built for the age of inference. So basically, for those of you who don't know much about inference training, etc. So there are basically three phases, right? First, you train the model, which is called the training phase. Then there's the inference phase, where the model generates some responses for new data based on whatever it has been trained on. And then there's something called serving. But I'll just talk about inference and training. Serving, I'll leave it for this particular video. But most of the people combine serving and inference as the same thing. So for the sake of this video, let's keep it simple as well. So Google is saying the Ironwood TPU is specifically purpose built for this age of inference, and it will be able to generate responses much faster than the previous generations. It will be able to do training as well, but it will be very much efficient than the previous generations at generating responses as well, because we all know that the LLMs that we have today, including Google Gemini 2.5, most of the focus is on generating the outputs much faster, right? So this is what one of the main features of this particular TPU is. Now let's talk about some numbers now, because this really fascinated me, right? Now Google is saying this is 10x much performant than the fifth generation TPU, and it can generate 5x peak compute than the V6 TPU or Trillium, in other words. Now you can pack 9,000 such chips and then train your models. Now when you do that, when you pack those 9,000 TPUs together, now that's a totally separate hardware, where Google has these pods. In the pods there are dedicated circuits for letting those TPUs communicate with each other, called ICI, interchip, interconnect, etc. So that's altogether different video. But when you combine those 9,000 chips, you will be able to generate 42.5 exaflops, 42.5 exaflops of compute power. Now, that is like 10 billion, right? 10 to the power 18 billion compute, right? And that's huge. I'm not sure what I can't even fathom, what can be done with that particular compute capacity, right? And just to put that number into perspective, it is 24x peak compute than the world's largest supercomputer, El Capitan, which generates 1.7x of compute power, right? So, that was huge. I myself haven't done any hands-on on that, but it just blows my mind thinking about that 42.5 exaflops. Now this is from just the raw power side of things. Now this TPU is also very power efficient as well, right? So it is 2x power efficient than Trillium V6 of TPUs and 30x than the first generation TPU which was launched back in 2018, right? So that's significant as well from the power consumption or power efficiency value of things. It's not just you're just getting a lot of power, but at the same time you are also able to pack much more compute in the same watt, right? So that's efficient power usage as well. Now, some of the real world use cases, right? So what it will be able to do, or in real world, what will be the use, right? So I took an example of these LLMs, enormous large language models, Gemini, Claude, OpenAI, right? So the main focus is, those responses. Now you'll be able to, get those responses much more faster. Then you will be able to embed these AI in applications which will be able to respond much more faster, right? Which is you don't have to wait, maybe a day to train your model, etc., right? You can just pack it in your application and then get the response much more sooner than compared to earlier, right? And also your AI lifecycle is shortened a lot, right? So for example, earlier it used to take you like 1 week to train some model. Now it will be maybe a day or hour, right? So those are some of the advantages. Now where you can use this, right? So for example, if you have a recommendation service for a streaming application, right? So what you can do is when a user is watching something, right? The model that you have trained, right? You don't have to train it or wait for it to train every week and then give the user some recommendation based on something they have watched a week back, right? You don't have to do that. You can just train it daily and based on whatever the user is watching right now, and then you can improve that recommendation in a much better way. Same goes for something like an e-commerce application where there's a fraud detection system, and based on any new pattern you can train that fraud detection system much faster compared to earlier what you used to do maybe a week or month, etc., right? So those are some real advantages, right? So as a DevOps engineer, I want you to be hyped up for this because it's too big a thing to miss out, right? It's not just another announcement, right? It's something significant for the future, right? Because as a DevOps engineer also in future you will manage the entire MLOps cycle or pipeline, right? So you should be able to know what is happening, etc., right? For example, if there is any slowness in any model training, you should be able to know, okay, whether the model code is buggy or the underlying hardware is buggy, right? Or how should you improve the hardware in a much better way so that you get optimum output based on your model code, etc., right? So that is what I wanted to cover. There are a lot of awesome announcements happened in Cloud Next, like relative same thing. GK inference got released, and VLLM support for TPUs got released. So a lot of cool announcements, and so I highly recommend you watch the keynote for Google Cloud Next. But I hope you like this video and you are hyped up for this next generation of TPUs. And let me know what you think about this in the comment section below. And if you like this video, you'll also like some of my other videos, which I'll post them here. And yeah, feel free to subscribe to this channel if you want to see many more awesome content like this. Until then, you get to live, make the most out of it. Thank you.